So I'm here to talk to you today about building reliable tools out of unreliable tools. And specifically, I'm here to talk to you about how to turn AI into something that is reliable enough that you can use it for doing AppSec. Why am I in the position of talking about this? So I'm currently field CISO at Clearly AI, which is a company which builds tools based on AI. And prior to that, I spent about 5 years at Amazon as a principal privacy and security engineer. Prior to that, I ran a machine learning research and development lab for Symantec. So I have worked the AI side of the house. I've also worked the security side of the house. And so I get to have a very unique perspective on how to glue these things together. So we're going to talk about why AI is both the problem and the solution. We're going to talk a little bit through what AI is and is not good at. We'll talk through some security-specific challenges that come up when you're trying to build these kinds of tools. And then we'll get into the real meat of the talk, which is getting the most out of AI for your security tooling. I don't know if you've noticed or not, but there seems to be a lot of AI going around. Everybody has inserted AI into everything. I'm sure I will be able to buy an AI-enabled toaster any minute now. And it's going great. It's going beautifully. People are using AI to vibe code things into existence. People who have not a lot of technical expertise are building things, as we heard in the previous talk. And these tools are intrinsically unreliable. Like, they are not deterministic. They are not necessarily going to write you secure code unless you know how to ask the right questions in the first place. And so we are producing unsecure code faster than ever. And while agentic AI is nifty, it does not resolve any of the issues involved. Still a little bit problematic. So what is the solution? The solution is you need to stop treating AI like a coworker, and you need to start treating it like a high-level programming language with some non-determinism. Yes, you can vibe. Yes, you can have a conversation with it. But when you go to build systems out of it, you need to treat it like a component of a system. And that means treating it like a programming language with no type safety, no input sanitization, and none of the other rudimentary security features that you would expect out of a programming language. That said, there are a bunch of things that AI is in fact incredibly good at. It is beautiful for processing a huge amount of unstructured context. It's very nice at turning that context into output, as long as you have clear requirements for what you're asking about. And if you have well-defined structured processes that you can turn into tasks, it will do them all day, every day. But it doesn't do well when you don't have clear success criteria or you're missing key information. It doesn't do well when there are high judgment tasks with no clear right answer. And it's not great in places where probabilistic outcomes are not acceptable. So if you want 5 nines of reliability, AI is probably not the right tool for you. So beware the door handle. So how do we get from vibe coding to reliable AI applications? We start by stepping away from prompt engineering, which is a very popular buzzword, and we start looking at context engineering. We start looking at task decomposition, which is the equivalent of going from spaghetti code to well-structured classes and modules and breaking things down into things with clear interfaces and boundaries. We start introducing type safety. That is a thing you can get out of your AI with the right tool stack, and it's incredibly powerful. We start looking at data contracts, and we ignore fine-tuning. But people get very excited about fine-tuning in much the same way that people used to get very excited about differential privacy when I was working in pets. And the reality is that you have so many other problems before you get to fine-tuning that you probably don't need it. So here's a guide from OpenAI talking about their suggestions for getting the most out of AI. And we'll elide some of the details, but even OpenAI itself says, hey, like, do some prompt engineering, get the right context, stick those things together, and you probably won't ever need to get to fine-tuning. If the model has the information that it needs to know, and you're using, especially with the modern frontier models, it has a lot of information about how it needs to ask, how it needs to act, if you ask the right questions of it. So fine-tuning is not necessarily something that you need to do unless you're doing something very specialized, but you can get a huge amount of power out of prompt engineering and context engineering. So when I say context engineering, what am I talking about and why are we doing it? Giving your LLM the right context is incredibly powerful and also incredibly easy to mess up. One of the things that people don't appreciate about LLMs is this notion of context compression or context collapse. The more you put into the context buffer, the less of it it's actually remembering and using when it goes to make the output. So if you can decompose your problem into small, well-formed bits of context and get back results from that, you're going to get much better results than if you just shove everything into a million token buffer and say, give me all of the results at once. And you will also not get good results out of this thing on the right, which I see a lot of people doing because it's a very classic chatbot conversational model of interaction. You are giving a little bit of context, getting back a result, and then you're keeping that context as you go on to add more context and ask another question. So this sort of additive, I'm going to give you more and more information in the same conversation, in the same context, actually does not work terribly well. So you really want to break things down into clean, well-defined questions, and then bring those results together at the end. I think we've all heard about agents, so I am assuming you're familiar with this idea of using LLMs as a way to call functions. And there's not a lot here that changes, except that you are now allowing the LLM to make choices about what functions are being called. But you're still dealing with this very probabilistic thing on the front end, and you're giving it access to potentially a wide range of powerful tools in the process of this. MCP is another layer on top of this, and MCP is basically just an abstraction layer for agents. MCP defines a standardized protocol, which gives you a consistent interface for discovering what tools are available, what calls are possible, and some modest structure on how things get returned. But it comes with absolutely zero type safety. Your options are plain text or a blob, as I recall. There's not even a proposal in flight for MCP. So this is a little bit useful, but it's not everything that it needs to be. So what makes security exceptionally difficult when we're talking about using these kinds of tools? First off, security is quite picky about probabilistic behavior. We really don't like it when our controls fail 5% of the time. So we want much, much more reliability than you're willing to put up with from, say, a chatbot. The other thing that's tricky in the policy, privacy, data governance space, basically anything where you are dealing with a large corporate body of knowledge, is that that body of knowledge isn't, pardon my language, but it is an uncurated cesspool. Like, you have policy docs, but you have all of the policy docs. Some of them have been superseded by other policy docs. It's not clear which one actually takes precedence, or if there's yet another one you haven't discovered yet. You might have conflicting guidance in different places in your organization, and you need to rationalize those. You have conflicts between what the architect said was going to be built, what the product manager asked them to build, and the code that actually got built. And you need to figure out which of these is relevant for the question that you're actually asking about whatever it is you're analyzing. And then there's monorepos. Monorepos are a giant blob of context if you don't do anything to structure them or to narrow down the scope of what you're asking about. So if you have a company that prefers to work in monorepos, like it's very challenging, and you need to figure out even how to pare it down to fit into the maximum context buffer size that you can get, let alone turn it into something useful that you can ask questions about. And yet, despite all of this, you are still asked to bring really, really good reliability to the table. But again, we are shipping insecure code faster than ever, and that means that you need to secure code faster than ever. So you have to find ways to scale. So how do we bring reliability to the table? How do we actually build tools that are going to let us do this monumental task? First off, you want to start rationalizing knowledge. You want to start taking everything that you know, and rather than just blindly asking questions of it, you want to ask the same sorts of questions that you as a security engineer would ask. You're not going to let an end user loose on all of the policy in the company. Like, they are not going to find the most recent version of it. They're not going to know what to do when the guidance conflicts. So instead, you want to look through things separately. You want to flag conflicts. You want to have human review those conflicts and say, here's what actually should, here's the source of truth, here's what should take precedence. You want to take that knowledge and you want to compress it down into a knowledge base. You want to pull out the relevant pieces of information so you're not burning tokens processing it over and over and over again. It's nice that you can hook an agent up to, say, your Confluence or your SharePoint, but don't call that data source more than once for every time it changes. Do some initial analysis, do a refresh, but pull out the information that you need. You want to work on hallucination prevention. This gets a ton of airtime, and there's a bunch of techniques that work surprisingly well. One of which is, as I described earlier, breaking questions down into smaller components. The more tightly scoped the question is, the less context you're putting into it, the more likely you are to get a reasonable and accurate answer. Chain of thought reasoning is helpful, asking the AI to walk you through the individual steps that it's going through to get there. First, because it will get to the right place better, and second, because you can check its logic if you don't understand why it made that call. Source citation, people don't think about this as nearly as much as they should, but just asking the AI to go back to the original document and pull out the source of its information can often flag a hallucination, because if it has to recheck its work, it will realize that the thing that's said isn't aligned with the underlying knowledge base. Prompt engineering does matter. Being able to structure questions, being able to ask them in the most precise way possible, bringing as much of your expert knowledge to the table as you can. You guys are, in fact, better at this than LLMs, I promise you. I've checked. And so if you ask the right questions of it, if you treat it like an intern and you say, here's everything that I know, here's the questions you need to ask, go get me this information, you're going to get much better results.
Actually, there's several more that you would want to put on here. One, it sounds obvious.
Mm-hmm.
Tell it, I don't want you to make up anything. I don't want you to show demos, do not test, basically don't make up shit.
Yeah.
That's one of just telling it don't do this to begin with is and you put that into a memory instead of just into the prompt itself.
Mm-hmm.
Then it has to always start with that. One of the others is that you simply ask it for confidence
Yes, which I think I mentioned up there.
Where do you have
There, confidence
Yeah,
scoring under prompt
confidence
engineering.
scoring.
Yeah.
The confidence scoring is absolutely huge.
Mhm.
But then one of the other big ones is, um, I'm assuming you're assuming a open-ended LLM, like you're just going to chat GPT and that kind of thing.
Oh, I think did you come in a little bit late?
I came in just a little late.
Okay, yeah, because I covered a little bit why it is that the conversational model actually isn't a good idea and why you don't want to do. Sorry, I'm getting a 5-minute warning. I'm gonna push you to the kibitzing section at the end. So, oh, that's 10 minutes. Okay, sorry, I thought that was a 5-5. Okay, but yes, all of what he said, and more so than don't make things up. Give the LLM the option to tell you, I don't know. This is, again, like a overlooked technique. Give it an I don't know option. Say, choose from these 5 options, or tell me you can't figure it out. Tell me you don't have enough information. And you'll get much, much better results out of it. And last but not least, don't use an LLM as your judge unless you can articulate clear success criteria, and the success criteria is smaller and less complicated than the question you asked in the first place. You're using the same LLM, the failure modes are going to align unless you come at the question from a different angle. Here's an example of, let me know if this is too small to read. I think it should be legible from the back of the book or from the back of the room. So when you're going to do LLM as judge, you want to be super, super crisp about the level of detail that you want out of the answer that you're getting. So, here we're saying, I want to see the specific RSA signing. I want to see this specific number of rate limits, like break it down into these very small, very binary, like yes or no questions about the thing that you're judging. And so the last thing that I wanted to talk to you about, so I think we are right on track for time, is I promised at the beginning of the talk I would talk to you about type safety and LLMs. And I want to talk about some of the tools that you have at your disposal to do that and why they are so incredibly powerful. So we use BAML all over the place in our stack because frameworks like BAML, a little bit Pydantic, but even more so BAML, allow you to take an LLM and treat it as the inside of a well-formed function that has input and output types that you can do type checking on. It brings you assertions. Basically, it allows you to take something that is inherently probabilistic and force it into the mold of something that works like code. So I have a QR code here. Everything in the demo I'm about to show you is online. It is open source. Feel free to take it, play with it. And let me. I just sort of, trotted it out and said, look, a cute thing. Let's see, where the heck is my, there we go. Give me one moment. All right. Yes, that's why I love putting QR codes up, because people will just scan them. It's amazing. But for those who are paranoid, I did put the URL at the bottom. Let's see, where is my cursor? There we go. Okay. And let me see if I can get dark mode turned off. Okay, I'm afraid we're going to have to live with it being a little dark because I do not see an obvious button to turn it off. Are you guys able to read this? Can you see it? Or is it too much of an eye trip? A little bit bigger? That I can do. There we go. Perfect. Okay, so what we're doing here is we're saying we want the LLM to extract some info from this doc over here. So this doc over here is just a free text, very high level specification for a system that perhaps an engineer is proposing to build. We're going to build a transaction enrichment service. It's an internal microservice. It's going to capture merchant details and category and geolocation, and just make the product very much better. So what we want to be able to do is we want to say, what are the facts that I can pull out of this? I want to understand what kinds of sensitive data are going to be handled. I want to understand who the threat actors are. And when I go to define sensitive data, I'm actually going to give you an enum. I'm going to give you a firmly typed thing that I want you to choose from. So you can have location data, you can have biometrics data, and you've got an enum again for your threat actors. And here, come on, scroll for me. There we go. All right. And then here we're actually going to pass in, this one will take either an image or a string. We're going to use GPT-4 because I haven't upgraded it. And what we're going to get back is a well-formed, structured Python object that adheres to those classes that we just asked for. And we are going to do that by calling an LLM and processing this. Oops, come on, work with me. There we go. I love it when live demos actually work. What's that? I did. Yeah, so what I'm getting back is, so this has been serialized into JSON, but I'm getting back a typed object that I can then go and work with. So being able to put things like type checking and assertion around your LLM models opens up a ton of options that you wouldn't otherwise have when you're starting to build tools for security. So it allows you to do things like doing type checking. It makes you much less vulnerable to things like prompt injection attacks. It doesn't completely eliminate them, but a lot of prompt injection attacks are less useful if you can't propagate the problem downstream. And so having firm boundaries on what kinds of types you're allowed to return is very helpful. And finally, you can do, like I said, you can do assertions. So you can say, here's the set of things that I'm expecting to get back. And so if I get anything other than this back, if I get anything other than this set of function calls and this set of parameters, I'm going to shut this down. So that allows you to be very specific about the kinds of behavior you expect out of this bit of LLM code. This is a great thing to put on the front end of your MCP because it ensures that the agent that you're building is going to stay within the boundaries of the intent that you crafted in the first place. It's much harder to take control of something and use it for malicious purposes if you've been really specific about what you expect it to be able to do. Okay, how are we doing on time? Perfect. So in summary, let me go back to my slides. Perfect. Amazing. Okay, so in summary, a lot of the context of your enterprise is data, not information, and certainly not wisdom. A lot of the context around what you need to do with that enterprise documentation can still be in people's brains. So take advantage of that. Use the LLM to uncover problems and surface them to people. Don't try to fix them on your own. Understand the limitations of the tooling. Understand why it is that you need to do context engineering. Understand why you don't want to just dump a million tokens in a window and expect anything good to happen. And use automation as a support for human judgment, not as a replacement for human judgment. Again, you're bringing your expertise to the table, and you do have expertise. You are the one who is making sure that the right questions are asked. You're the one that's making high judgment call decisions. You're having the LLM surface information to you much faster. And the nice thing about this is it allows you to do a much tighter closed loop. I was in a talk earlier today where somebody was talking about risk management, and they were talking about the disassociation between what the threat model says and what controls actually wound up being in place. And you do your framework analysis once a year, maybe you do your vendor risk analysis once a year, and by the time you get to the end of that year, everything has changed. So having tools like this allows you to tightly connect. Here's the threat modeling. Here's the controls I asked you for. Did you put them there? And I'm going to continuously test as you iterate on this because I can pass the specification along and I can generate it automatically. So super powerful. Feedback is a gift. I am always happy to receive it. They've given me this lovely QR code. I am not responsible for this QR code. If anything bad happens, it wasn't me. But I would love to hear your thoughts. And I think we have 4 minutes for questions. You good?
So
Yeah.
you mentioned BAML,
Mhm.
and you have a structured output of the LLM.
Yeah.
What is a good strategy for when you have an error? So like either it doesn't actually format, so the LLM just decides it doesn't want to follow it.
Yeah.
Do you just error out and then fail, or is it like, hey, let's ask again? Or what are like some good strategies for that?
Yeah. I mean, I would think about it the same way you would think about any other piece of code. You need to decide what is the cost of making a mistake? What is the cost of just throwing up your hands and saying, I fail, I'm going to throw an exception, something is broken, versus retrying, bringing in, maybe some new information. So think about it exactly the same way that you otherwise would. Think about what recovery looks like if you were to do this in code, and then engineer for that. Yeah. Yeah.
And it uses a lot of same element that the area will make more there's kind of correlation.
Yes.
I just wanted to know what your thoughts are on using a different element. You have one element that is useful, and you have different element that you use as such, so that since they're different, there's you remove the aspect of correlation.
So there's this deeply technical thing that you learn when you're doing machine learning research, which is called model convergence. And basically what it says is that if you have two models which are trained on roughly the same training data, you will get convergent architectures. And so there's usually, like, for example, if you're doing adversarial attacks in model A, they will transfer to model B if you trained it on the same data. And so LLM failures, even when you're looking at Claude versus ChatGPT, you are going to see a lot of correlation because realistically they all trained on all of the data. And so they're very, very well aligned in terms of how they fail. So you want to come at it from the direction of the context and the prompt, not just tweaking the model parameter. Yeah.
Did you happen to have anything locked and loaded just as far as specific examples maybe you'd use for prompts where I believe you were talking, maybe this is already in the slides, but you were talking about ways to prevent hallucinations via like instructions given. I was wondering if you had any like specific
Is this the triax room?
Yeah, I don't have a backup slide for this. And I think, he covered some of them, I covered some of them, but it's
Just Wayne McDaniel's too.
small context, precise queries, give it an out. Like if you, LLMs really want to be helpful, and it
Just don't know the right.
is a great, yeah, exactly. Like they want to be helpful and they don't understand that giving you a bad answer is worse than no answer. So if you only say pick from these 5, they're going to pick from that 5.
So that's probably going to be this room here.
Okay, the triax.
Yeah. You can enter through this door.
What it knows about, thereby it can't really hallucinate as long as you're in context what it actually has been told about, which will allow for everything to come out in a better way.
Asterisk.
There is another thing of, basically, if you have a conflict,
Yes.
give me both answers.
No, yeah, that'll work out.
Yeah. I'm going to dissent with him a little bit. What he's saying is mostly true, but with a sufficiently large context, you'll still get hallucinations. So it's not perfect.
There is no
But-
perfect.
yeah.
We're not.
Yeah. I'm agreeing with you. I'm adding the asterisk.
It's hard
Yeah.
to-
Well, what you gave was definitely super usable. Thank you.
Good. I'm glad. That was the goal.